Hey everyone! Welcome back to our MCP series. In the last video, we learned about REST versus JSON-RPC and how the MCP uses JSON-RPC for its communication. Today, we are finally going to build our first MCP server from scratch. An MCP server acts as a toolbox that an AI assistant can access whenever it needs specific tools to respond to a user query. Let's start building. First, we'll install UV, a modern Python package manager written in Rust, designed to be much faster and more reliable than pip. Once UV is installed, we'll run UV init. This command sets up the project structure for us. On the left, you can see the main.py file along with the other generated files. Now, we'll create a requirements.txt file. This is where we list all the dependencies and libraries needed for our MCP server. For now, we'll just add MCP and FastMCP. FastMCP is a Python library that makes building MCP servers super easy. Instead of writing hundreds of lines of code, FastMCP lets us build a server in just a few lines. Now let's clear the terminal and install our dependencies. We'll run UV add our requirements.txt. This installs all the libraries and automatically sets up a virtual environment for us. All our libraries are now installed. We'll be building two MCP servers, one using STDIO transport and another using HTTP transport. We'll start with the STDIO-based server, which is typically used for accessing tools locally. For this, we'll create a server.py file and begin building the server. So first from mcp.server.fastmcp. Import FastMCP. So, we are importing the FastMCP class from the MCP library. This is the main building block we need. We are creating our MCP server instance. That name parameter is just a human-readable name. This is what clients will see when they connect to our server, so here we have kept the name of our server as demo server. Second is our instructions parameter. It basically tells the AI assistant, like Claude, what this server does and how to use it. Think of it as a user manual for the AI. So here we will write instructions as this server provides mathematical calculation tools. Next we will add @MCP, which are instance. .tool. This is called a decorator. It's like putting a label on a function that says, hey. This is a tool that can be used by the AI assistant. Without this decorator, our function is just a regular Python function. With this decorator, it becomes an MCP tool. Now we will write the async function. We use async def instead of just def. This means our function is asynchronous. It can handle multiple requests at the same time without blocking. Don't worry too much about this for now. Just remember to always use async definite for MCP tools. The function is called add and it takes two parameters, a and b. Both are numbers that we want to add together. The float here is a type hint. It tells Python and the AI that both a and b should be floating point numbers, numbers with decimals. The dash float at the end means this function returns a float. This docstring is crucial. The AI assistant reads this to understand what the tool does. It says, add two numbers together and return the result. Clear and simple, exactly what the AI needs to know. We return the sum of a and b. When the AI calls this tool, this is the result it will receive. It can then use this result to continue helping the user. Imagine a user asks, what's 127.5 plus 89.3? The AI would call our add tool with those numbers, get back to 116.8, and tell the user the answer. This is our main function, the entry point of our program. When we run this script, this function gets called. mcp.run starts our server. The transport is equal to STDIO tells the server to use STDIO transport. STDIO stands for standard input output. When your MCP client is running on the same machine as the server, the client starts the server process and talks to it directly through input and output streams. Finally, we add this block, if __name __ is equal to __ main __ main. This tells Python to run the main function only when this file is executed directly. It prevents the code from running automatically if the file is imported somewhere else. That's our complete STDIO MCP server. Let me save this file. Now let's run our server. Make sure you are in the server folder. We use uvrun to execute our Python script. Notice the server is now running. It's waiting for connections. The terminal won't give you a prompt back, it's actively listening. With STDIO transport, the server waits for a client to connect and send it messages. When a client connects and asks to use the add tool, this server will respond with the calculation result. To stop the server, press Ctrl+C. OK, now we will start building our HTTP server. So I will create a new file and name it as demo_http_server.py. Same as before, we will import the MCP library. So we type from mcp.server.fastmcp import FastMCP. Then we will create our MCP instance. It will be MCP equal to FastMCP, so the first parameter is the name of our server. I'm calling it demo_http_server. That's our first parameter. Now, we could add instructions here like we did in the STDIO server, but I'm not keeping it for this example. We'll focus on the HTTP specific parameters. So let's add port. Port is nothing but it's like a door of your apartment, where your MCP server will listen to the requests from the client. I'll set it to 8001. So our server will listen on port 8001. Next is stateless_HTTP. We have set it to false. This basically maintains the state between requests. It remembers things. If we set it to true, the server won't remember anything between requests. Each request would be completely independent. But we want our server to maintain state, so we keep it false. Next is our streamable_HTTP_path. This is the path where our MCP server will listen for requests. I'm setting it to my_MCP. So the full URL path will include this. And then I will mention the host. We'll keep it local, it's pointing to our own machine. I'll set it to 127.0.0.1. This is the localhost address. So our complete URL will be http:// then your host address 127.0.0.1, then colon, then your port number 8001, and then your path my_MCP. This is how the complete URL looks. OK, next we will create our tool using the decorator. So it will be at mcp.tool. Now we'll add the same add function that we used in our STDIO server. Let me copy it from there. Now, in order to differentiate which server we are using, whether it's the STDIO server or the HTTP server, I will modify the return statement. So I'm using an F string here. It will return the sum of A plus B equals to the A plus B. So if someone calls add 5, 3, it will return the sum of 5 plus 3 equals 8. This way we know the HTTP server is responding. Now let me copy the main function from our STDIO server. But here, instead of using STDIO transport, we need to change it to streamable HTTP. So I change the transport parameter to streamable HTTP. This tells FastMCP to start an HTTP server instead of using standard input-output. And that's it. Our HTTP MCP server is complete. Now let me run the server. We will do uvrun and server file name, that is demo_http_server.py. Look. It's giving us a URL link on which the server is listening. Important, keep this terminal window open. The server needs to stay running so clients can connect to it. That's it for this video. We've successfully created and started our STDIO and HTTP MCP server. In the next video, we will build a client and an agent. We'll see how the client connects to our servers, both STDIO and HTTP, and how these servers fulfill the requests from the AI assistant. If you found this helpful, hit that like button. Subscribe for more MCP tutorials, and drop any questions in the comments. Thanks for watching, and I'll see you in the next video.